Hey, Dan here, and welcome to Fun Kids Science Weekly, Reach for the Sky Special, the podcast that explores the future of aviation, from the design and sustainability of future planes to the people who keep them flying and make sure our experience is top-notch. In this podcast, we're answering your questions. We asked you what you would like to know about planes of the future, and I have to say, there is a lot. Hundreds of you got in touch. So, we'll get to that. And first, let's get off to a supersonic start. Here's Amy.
Amy Aviation's British Aeronautics.
There are loads of places around the UK which are associated with Britain's aerospace industry. Some of them might be near to where you live. Let's spin the propeller and see where we're headed today. It's Bristol. Get ready for takeoff. Bristol is in the southwest of the UK. We're headed for Filton, a place which has a long aviation history. Airplane production began here over 100 years ago in 1910. Filton was home to the Bristol fighter plane that was used to defend the skies in the First World War. It was the Spitfire of its day. It's also where the Blenheim was made. That was a fighter used by the Royal Air Force in the early days of World War II. Filton has also been home to the manufacturer of helicopters and even satellites. But one of its most famous developments was Concorde. Concorde was a passenger jet developed by the British and French. It was launched in the 1970s and could travel at supersonic speeds. It could fly between London and New York in as little as 2.5 hours, reaching speeds of 1,300 miles an hour. This incredible plane was designed and assembled in Filton. 20 planes were built, but only 14 ever entered service. The cabin was quite small, with room for only 120 passengers. Compare that with over 600 who can fly on an Airbus A380. Concordes don't fly anymore, and although in their day they used some of the most advanced technology available, they now take their place in aviation history. You can see the remaining Concordes at airfields around the world, including at Filton. But the idea of supersonic travel isn't over. With advancements in materials and aerodynamics, a number of companies are looking again at supersonic passenger planes, and we may well see one within a decade. It's time for me to take to the air again. See you next time.
Amy Aviation's British Aeronautics, with support from the Royal Aeronautical Society. Find out more at funkidslive.com/Amy.
Concorde was definitely an iconic aircraft. It's exciting to think about what the future might bring to aviation. And as I've said, we've been going through hundreds of your questions. So let's do it. Seatbelts on and get ready for takeoff. Let's launch our first question then. Alice asks, do you think there will ever be a flying hotel like a cruise ship but in the sky? Okay, aviators have been thinking of what that might look like, and one idea is the fantastic sky cruise concept. How amazing would that be? Giant windows, luxury rooms, epic views above the clouds. Here's the thing, building something like this just isn't possible with today's technology. Why not? Well, a floating hotel would be absolutely huge and really heavy, and current engineering can't handle something that massive zooming through the air. There would need to be something enormous powering it, and that might be something like super stable nuclear fusion, which we just don't have yet, and it might need incredibly advanced artificial intelligence to help it fly safely and to dodge turbulence. And even if AI could help steer it, the physics and aerodynamics of such a colossal craft are mind-boggling, and making sure a nuclear-powered flying hotel stays safe would be a massive challenge. So for now, it's a good idea, but the sky cruise will have to stay an amazing dream of the future rather than the real thing. Now, Tom wants to know, how high can the plane actually go, and at what speed can it travel? Great question. Most commercial aeroplanes zoom along at around 560 miles an hour. That's nearly Mach number 0.8, or just under the speed of sound. And they cruise way up at 30 to 42,000 feet, which is about 9 to 12, it's about 10 kilometres high. But why would you go that high? Well, the air up there is much thinner, which means there's less drag holding the plane back. That means the engines use less fuel and the plane can fly more smoothly and efficiently. You're also way above clouds and storms, so you don't get bounced around by turbulence as much. Now, here's a cool trick. As the plane burns fuel, it gets lighter, so the pilots can gently climb even higher during the flight to stay in the sweet spot for speed and fuel savings. Now, they could go faster, but they don't. And that's because flying at the top speed would burn loads more fuel and wear out the engines. So they cruise along at just the right balance of fast, smooth and economical. Sam's up next, asking, will planes ever have wings that flap like birds or flip over like bees? That's a brilliant question and a lot of fun, isn't it? Big planes don't flap their wings because fixed wings and engines are way more efficient for carrying lots of people and cargo. When air flows over a plane's steady wings, it creates lift, while the engines provide powerful, steady thrust to push it forward. This design gives planes the speed, the range and the altitude that they need to zoom across the world, something flapping wings can't manage at that size. But scientists are always inspired by nature. They've built special flying machines called ornithopters that flap like birds, bats and insects. There are even tiny bird-like micro-ornithopters used to watch crops, check in on crowds and study wild birds without scaring them away. Some engineers are creating robo-bees, which are teeny robot insects with bee-style flapping wings that can hover, zip, and turn super sharply. These nature-inspired flyers are not meant to replace big passenger planes, but they're designed for special missions where flapping or shape-changing wings would be really handy. So while the jet you go on holiday in won't be flapping anytime soon, the skies might soon be buzzing with clever mini flyers inspired by birds and bees. Here's Lily. This is an interesting one, Lily. If fighter planes can be refueled in flight, why can't they do the same for long-distance holiday flights, like going to Australia? While that does sound like a great idea to get rid of stopovers for refuelling, it just isn't possible. Because, well, mid-air refuelling is super dangerous. Imagine trying to plug a hose into a giant jet zooming through the sky. One tiny mistake could cause a catastrophic crash. Military pilots spend years training to carefully guide their planes into special refueling baskets while flying in perfect formation. That level of precision is far beyond what commercial pilots are trained to do, especially with huge heavy airliners that aren't very nimble. It's also really expensive. You need a whole fleet of tanker planes, plus specially trained crews and equipment, which would send ticket prices skyrocketing. And honestly, it's just not needed. Modern long-haul planes like the Boeing 787 and the Airbus A350 are already built with enormous fuel tanks that let them fly to places as far away as Australia without stopping. It just might take 22 hours to get there. The only people that really need air refueling are the military, because they must fly extremely long distances to complete their missions, and they care more about global reach and mission success than things like passenger comfort, whether you're having a nice time, or ticket costs. So while it's a cool idea, commercial planes are better off fueling up on the ground and flying safely all the way to their destination. In our series of podcasts, we've heard from a huge number of experts. Some of them have given us their thoughts about the next question. Here's one from Romy, who wants to know, what do you think air travel will look like in 100 years' time? So all the experts we've talked to had their own wild ideas, but here are some of the big things that many of them agree on about the future of flying. First off, expect a huge push for greener travel. Planes might be powered by electric or hydrogen engines instead of fossil fuels, especially for short and medium distance flights. They could be built from super light composite materials and shaped in sleek, blended wing designs to save loads of energy as they slice through the air. For quick journeys around cities, we'll probably hop into eVTOL air taxis, tiny aircraft that can take off and land vertically, zipping people from home to airport like flying lifts. Meanwhile, autonomous aircraft might fly themselves for short hops, while supersonic and even suborbital planes could zoom across the globe in just a few hours for people who need maximum speed. Inside the cabin, things could get seriously futuristic, perhaps holographic flight attendants handing out snacks, while real crew focus on important tasks, and even 3D printed goodies made just for you. Cabins could be more spacious with natural calming decor to help you relax. And who knows, some people might even slow down and rediscover the magic of flight, choosing gentle, scenic airships instead of fast jets. On the flip side, worries about climate change could bring stricter rules or even limits on how often people can fly, pushing engineers to totally reinvent air travel. The only thing everyone agrees on? Flying in the future will be very different and very exciting, I'm sure. Next up, a rather more colourful question. Misha wants to know if you can fly through a rainbow. Unfortunately, the answer is no. Although that would be very pretty. Imagine zooming your plane straight through an arc of colours. Here's the thing, a rainbow isn't actually there to fly through. It's not a real object like a cloud. It's an optical illusion made when sunlight reflects and bends or refracts inside tiny water droplets in the air. A rainbow is a trick of light and geometry. To see one, the sun, water droplets, and your eyes all have to line up at the right angle. If you move, that angle changes, and the rainbow moves with you or completely disappears. So even if you aim straight for it, you'll never get any closer. It's always the same distance away, no matter how fast you fly. So while flying through a rainbow sounds magical, it's scientifically impossible. Let's get this one on from Isabella, who's asking if planes have keys, like a car key to start the engine. Great question, and the answer is yes and no. Small aircraft do often have ignition keys just like a car. The pilot pops the key in, turns it, and the aircraft starts up with a roar. These little planes also have keys for locking the doors, baggage compartments and fuel caps, especially handy when they're parked outside at smaller airfields where security might be looser. But big commercial jets are totally different. Commercial airliners don't use keys at all to start their engines. Instead, pilots follow a carefully timed sequence of switches and buttons in the cockpit. They often use compressed air from something called the auxiliary power unit, or from external ground power, to get the engines spinning before they ignite. And here's another surprising bit. Airliners don't even have locks on their main cabin doors. They don't need them. The air pressure inside the plane keeps the door sealed tight while flying, and on the ground, planes are kept in super secure airport zones. So, little planes have keys, big planes don't. They've got buttons, switches, and a load of safety systems instead. Now, we've had loads of questions thinking about how planes could be cleaner and greener and even help contribute towards renewable energy. James is closing the show, and he's given this one some thought. As planes fly near to the sun in the sky, why don't they have solar panels to collect energy while they fly? Now, that sounds like a brilliant idea, using free sunshine to fly, but sadly, commercial airliners can't run on solar panels, at least not yet. And here's why. Big jets need a huge amount of power to cruise over 500 miles an hour, and solar panels just can't make enough energy to do that. They only capture a small slice of the sun's energy, and you need an enormous area of panels to get even close. Even then, solar power varies with clouds and weather and time of day, so it's too unreliable to run something as demanding as a passenger jet. Solar panels also add weight, especially with the heavy batteries needed to store the power, and their rough surfaces create drag, which slows planes down and wastes fuel. They're also not built to handle the stress of high-speed flight, and adding them would make the aircraft more complicated and expensive to maintain. Planes like Solar Impulse 2 have shown that solar flight is possible, but only with tiny, lightweight aircraft that fly very slowly and carry no passengers. They're nothing like the big jets that we travel on. For now, commercial planes stick to powerful jet fuel for thrust and speed. Solar, one day, might help with small onboard systems like lights or screens, but it's not nearly strong enough to power an entire airliner. Amazing questions, guys. Thank you for those. There are loads more brilliant facts about aviation on the website, so find out more funkidslive.com/aviation. On there are also details of the amazing careers available, from the top of the control tower to the baggage handlers on the ground, and we've just enough time to check out a few you might not have heard of before. Love computers? Are you fascinated by how things fly? Or maybe you're the type of kid who enjoys solving puzzles or building gadgets? Well, then you could be part of the next generation of aviation superstars. Here are just a few of the awesome jobs that you can look out for. If you love hands-on tinkering with tech, being an electrical and avionics engineer could be perfect for you. Electrical and avionics engineers build, connect, and test the electrical brains of the aircraft. They work side by side with designers, flight testers, and production teams to make sure every wire, sensor, and screen works perfectly, turning exciting ideas into real flying machines. If you're into coding, computers, and big problem solving, how about being a software architect and engineer? These engineers create the software that controls everything on a plane, from flight controls and avionics to energy systems and safety features. They plan out how all the systems talk to each other, build software that's super reliable and safe, and make sure it meets tough aviation rules. Or maybe you're fascinated by how things move through the air, and you love maths and physics challenges. Well, aeroelastics engineers figure out how an aircraft's structure bends, flexes, and reacts to air forces. They make sure the plane stays safe, steady, and super efficient in all conditions, from gentle takeoffs to high-speed climbs. There are so many ways to help build the future of flight, from coding the computers to wiring the systems to shaping the wings themselves. If you love tech, teamwork, and a challenge, aviation needs you. Amazing. And with all that, it's time for us to head to departures. And I hope you can join us again soon. Fun Kids Science Weekly Reach for the Sky Special, created with support from a CAA Reach for the Sky Challenge grant. Find out more at funkidslive.com.